underwater. I don't understand how this works, but Uncle Joe, tell us, what are you doing with the computer?
Well, hello, Patty. This is really an incredible experience, and I love being here on E-Wired Underwater. I have a special computer with me and a new type of mouse. Now, we've heard of wireless mouse and optical mouse. This is a new one called a Hydro mouse, and what we can do is push it around and click. So what I'm going to do, Patty, is I'm going to send a special email message to everybody in the program watching now, and I'm also going to send you, via my Hydro mouse, a few of these pictures of some of the animals that we're going to be studying in this incredible underwater program. So this is lots of fun, E-Wired Underwater.
We're going to go up to the surface here and meet the rest of the participants of the program and check to see if Uncle Joe's email message actually went anywhere.
Boy, a little wet here, but we're going to join you here for a few minutes, and we look lovely, but we just came out of the water. We want to interact here with the students that are in the classroom. We're going to be going back into the tank, so bear with the wetness here. Feels actually kind of cool, doesn't it?
It's nice.
Now, today, like we said, we have Uncle Joe with us, and we also have a group of students here, as you'll see, sitting at the tables that are going to be doing a lot of different experiments and activities with us throughout the next couple of weeks. I'd like to take the first question, though, that we had, the think time question, and think about ways you can explore and research the underwater. It's what we want to look at today. When we say that the underwater is wired, we're looking at different technologies that can be used to get down underwater and see things and learn things that otherwise would be a little difficult. Now, we've put the question out. We've got some kids from Manatee Elementary in Florida who, let's see what kind of answers they have and what would be ways that you guys might go and explore. Manatee, who is there?
Jessica.
And Jessica, what might you use to explore the underwater?
I would use a submersible. I would have a robot.
And what would you do with the robot?
I would use it to record down the data that I found.
Let me go to Kealakekee here on the Big Island. Now, Florida is going to use submersibles and robots. And Kealakekee over on the Big Island there, what would you guys use and who is there?
This is Donovan.
Okay, and what would be some other things you might use?
I would use a glass bottom boat, submarine, and I would go scuba diving.
Okay, great. Several different ways that you can get down there, and we're going to show you some of these, and we're also going to go a little bit farther than that. Now, before we go into the tank, let's take a look here at one way that we can hear things underwater. Uncle Joe, what is one way that we can hear?
Well, Patty, when you and I talk, we have microphones. But underwater, a regular microphone really wouldn't work. And so what we have is something called a hydrophone, an underwater microphone. Now, this is in a little torpedo-shaped object with a wire onto it. The microphone is built into the side so we can actually tow it underwater. Now, what we're going to do as an experiment is we're going to put this into the tank. We have a little amplifier that we're going to turn on. Now,
okay, let's try something else, you guys. Something that's cool here in Hawaii that we can hear underwater is the whales. When the whales are down here, they sing. And they're singing what they think is almost a mating song. So the whales are singing. When you're snorkeling, if you're close to them, you can actually even hear it. So we got a couple girls here who are going to sing us a song, and let's see if we can all figure out what is the song that they are humming through the straws. Okay, go for it. Song, guys, is what? Okay, row, row your boat.
Very good.
Now, Joe, what would be some other reasons for using, I mean, we've played with this here, but why would scientists use the hydrophone?
Well, many things that we want to do is we want to record images as well as sounds, and the sounds give us great clues as to what the animals are doing, either feeding or communicating, and by analyzing information from the hydrophone, we can learn a lot more about our environment.
Okay, sound carries through the water better than it does through air.
It's about 5 times better in water than it is in air, mainly because of the density of water compared to air.
And you guys might want to go home tonight and try a straw, singing in the bathtub underwater, and you're not going to hear half of what these guys do. We got a new choir here. Now, we're going to go back down underwater here and take you back down again, and we're going to talk about some other technologies. But while we're going down underwater, I need to have Tim, to give us a chance to get back underwater here. Will you tell them, this is Tim Moline, and he's going to tell you guys how you can interact with us via the internet and other information. So Tim, while we get in the tank, go for it.
Have a good one. Don't get wet now. Hi, everybody. This is Jared. He's my buddy from Kalailani Elementary School. He's a fifth grader. And he's going to tell you what the website address is. So, Jared, what's the website? Where do they go on?
www.kidscience.net.
Great. Now, when you get to the website, you're going to see an area called Student Interaction. And at that, you want to go to Underwater Classroom. And there you're going to find, for the teachers, you'll find a guide that has a lot of background information and reading for the students and whatnot, so be sure to explore that. You'll also have links, I think, to, we're going to put up links for a slideshow that's going to be presented by Uncle Joe, and also some links to the Waikiki Aquarium, where you can see the shark cam and various things that are being... Okay, they're underwater now. Bye, and I hope that they're coming up nice and dry for you. Maybe not, though.
I want to talk for a minute here about how we are actually breathing. We have a hose that sends the air down into us, and as long as the air is coming into the helmet, I'm comfortable, I can breathe. But now Mark's going to show you what happens when he takes his helmet off. So if he takes his helmet off his head, he's got to hold his breath. See him holding his breath there? He can take his helmet off, and as long as he holds his breath, he's fine. But to get, when he runs out of air, he's got to put the helmet back on, and you'll notice it fills right up with air, and he's got air in there and can breathe. Now, let's show when you tilt a little bit to the side. He can also fill it partway up with water, and you can see it halfway get with water there. He's got it filled with water, but then again, he puts it right side up, and there's enough air coming in that hose that it pushes it right down. Now, this is cool. This allows us to breathe. But again, we're kind of limited to where we can go. We don't get to move around a whole lot because we have troubles walking, and again, I don't want to fall over and lose this helmet. Now, let's take a look at a different kind of technology, and this is using scuba gear. Now, Uncle Joe doesn't have a helmet on like we do. He can do a lot of stuff that we can't do on here. So, Joe, tell me about the scuba gear. How can you move, and what can you do that I can't do right now?
Well, Patty, the technology that I have is a little bit different. It's called SCUBA, S-C-U-B-A, stands for Self-Contained Underwater Breathing Apparatus. So my air, Patty, is in this tank on my back. It holds 80 cubic feet of air. Now, 80 cubic feet is a lot, so we compress it down inside this aluminum tank at a pressure of about 3,000 pounds per square inch. So I'm not burdened by the line that you have for your air. Now, that means that I can swim around, I can move up and down very easily, I can take care of myself, and I can control my buoyancy by putting air into the little vest that I have. Now, having this flexibility to move around, this freedom, is very, very important for a marine scientist. And the reason is I can go out and follow the animals, explore the environment much easier than you can. So I can do things like use an underwater camera, swim up to the fish, swim underneath the ledge to take an incredibly good picture, hopefully. But you would be limited to the short range of your hose. So the idea of scuba gives me a tremendous flexibility, the ability to move around.
What kind of cameras are you using down here to pick up some of these images?
Well, Patty, we can use a number of different types. We can use a still camera, much like many of you have used before. Now, this camera has an underwater light connected with it and takes 35 millimeter film, but it's limited to about 36 pictures. So, another type of camera that we use is video. And of course, the video camera is a little bit larger. It has an underwater light. So I'm going to come over and take this video camera from my cameraman Les and move it in front of another camera to show you exactly what this looks like. Okay, so I'll place it in front of a second tiny camera that we have here. So we're looking at an aluminum housing with a Sony camcorder inside. It has an underwater light that you see. I have a switch on the back so I can turn the light on and off. It has controls on the side so I can zoom in, I can start, I can do telephoto. And it has a series of cables, and these cables provide the video signal to the surface. Now, on the front of this is a underwater lens, and the lens has, let me turn the light back on, the lens has also a red color correcting filter. Now this is kind of a very interesting feature because we know underwater if we turn off the light and we were to take off this red color correction filter, which I will do right now, it's on by tape, the pictures would be completely different. They would be kind of dull. So let me swing the camera around here to Patty and Mark. Now you're seeing pictures here without a color correcting filter or without light. Now what's the difference when I put this color correcting filter back on? I will pass it in front of the lens and you can see the color is increased considerably. Now I will also turn on the underwater light in combination with the filter. So here we have the light and the color correcting filter. The light and the color correcting filter. Oh, you got a nice smile, Mark. But again, in contrast, I'll pull it off and look at the difference. Now, we have another type of camera. And this is a small one that I've helped develop. This camera is a very tiny thing. It's only about 3 inches long and about 1 inch in diameter. And if you look inside, it has 6 tiny white light-emitting diodes, some solid-state lights. The cables that you see on the back of it here helps provide the video signal to the surface and brings power down to the camera. If you notice on the front, there is also a red color correcting filter. Now, as we look down to the bottom, you notice the pole is on a very simple tripod. Now, what I'm going to do is actually come up in front of this camera. I will put my color correcting filter back on, and Mark has some lettuce. Now, this lettuce is kind of interesting because fish absolutely love it. Many of the fish that we have at Sea Life Park are vegetarians. These fish often are known as grazers. And as a scientist, we can use technology such as this, miniature cameras placed in front of a food source, to really study animals, study their populations, their behavior, and their preferences in diet. So it's a lot of interesting technology between video cameras, still cameras, and communication equipment that help us as scientists really understand this environment. So it's back to you, Patty.
For a minute and let you watch the fish eating the lettuce while we get out of the tank and come back into the studio and take a look at a few more types of cameras that we've got that we can learn some different things about. So while we're getting out of the water again, watch these fish. If you can see the teeth up close, how are they eating? Do they chew it? Do they swallow it whole? And can you hear them? So we'll join you out of the water in just a minute.
Okay, back out again. Boy, this is tough going in and out of this tank this fast. And again, we're a little wet here, but we're going to dry off now. The question that we left as we went down was, or as we came out, was what did you notice about the fish eating? That camera's so awesome because it's so up close to see what you see with that. What's something you observed with them eating?
They had no hesitation. They just went up and ate it.
So it's like they didn't know the camera was there, did they? No. Okay. What's something else you noticed?
And all the fish liked it, not just all different kinds.
They all ate the lettuce that was there. Something else you noticed?
They really enjoyed it.
They enjoyed it. Okay. And one of my questions was, why don't the fish eat the camera? And it's because they're vegetarians, right?
That's right.
And they're going to eat just the lettuce and not the camera. There could be a point where when you have a camera or something like that, that an animal might come up and chew on maybe the wires that are down there, whatever. And I know they're a little concerned when we're down there about the turtle. There's kind of an aggressive turtle. Well, it's a curious turtle that was going to chew on the cords, but cool seeing that, isn't it?
Yeah.
And could you almost hear them?
Yeah.
Yeah, what I got was that they were just really snipping at that stuff. Now, we can use cameras. Joe and I can be underwater. Joe was in a scuba tank. Mark and I were in what is called Sea Trek, and those helmets that we had air coming down and we could breathe with that. But you can also do scuba dive, which Joe was doing. But we want to show you how you kids at this point can get involved in this. Let's take a look at this.
The Bubble Maker program was designed for kids 8 to 11 years old to have their first scuba experience. They get to actually breathe off of the regulator. They'll go under the water in the pool to a depth of 6 feet. And we have games that we play with them to teach them a little bit about buoyancy and, the characteristics of being underwater. We have BCs designed specifically for children. This right here we're looking at is a SASE unit. We use this for children beginning at the age of 5. They're in a different program and they don't actually go under the water, but they just do snorkeling on the surface of the pool using a regulator and this unit. But it fits just like a vest, a little jacket with clips that are secured there. It has a little tank for them so that it's designed to fit their body better. And then we have a little regulator for them, and they also have a depth gauge and a pressure gauge. In the Bubble Maker program, this also works for them. The kids will put this on. Usually we put a bigger tank on the back so that they have a little bit more air time underneath the water. Children completing the Bubble Maker program will receive a certificate and their own little wallet dive card. And then we also give them a passport called Patty's Passport to Adventure, where they can actually log their experience. And it encourages them to take the next step and go on and continue their dive training. And the whole Bubble Maker program was developed to be an introduction to the sport of recreational diving. And it gives the kids a nice, safe, unintimidating experience in the pool to learn scuba and learn the equipment and have the experience.
I thought it was really fun because it sort of made me feel like I was a fish, and I sort of sank down to the bottom and I could swim pretty fast with this thing, and breathing was good because then I don't have to go up for air every 2 seconds. So it was really fun learning how to breathe with compressed air and learning all different techniques in order to scuba dive.
The most surprising thing was to me is that it felt really different compared to swimming on top of the water.
It's like a fish. Like, you just swim around there and stay down there and just swim around. I was underwater and I was doing this thing where I would throw the thing, air container thing away, and then when I tried to get it, I'm like, air, and I had to really listen to understand what time to get it and how you have to breathe really big first, and it was complicated.
When you have to put your fingers in between your mask and your face and fill your mask up with half of it with water, and then you have to take the water out and then just keep on diving. That was the hard part.
When we had to put water in our masks, and I couldn't do it. I had to go up for air and clear my mask because I got it. I'm wearing a wetsuit because, like, maybe it'll keep me buoyant a little, and it keeps me warm, and it's pretty comfy. It's just hard to get on. I'm sure it's going to be hard to get off, too. We're wearing weights so we can stay down in the pool and so we won't float up, because our weight isn't enough to keep us down, and weights help us so we can go as deep as we need to in order to swim around and do stuff.
The Bubble Maker program is the first step towards PADI certification. Kids going through the program gain entry-level experience, but it doesn't certify them to go out in the open water. Their next step after the Bubble Maker program is to continue on with the PADI Junior Open Water Diver program, which will allow them to actually go out into the open ocean and discover the wonderful world underwater.
You have to sort of know what you're doing in order to like know how to scuba dive and be able to have fun underwater instead of gasping for air.
You know, it was several years ago that Uncle Joe convinced me I needed to learn how to dive, and it's like, I can't do this, I'm too old for this. And I actually did learn about 4 or 5 years ago, and it's the most awesome thing that I ever did. Being underwater like that is really cool. And it was really fun to get these kids down. Now, what was probably one of the most important things that you learned or came out of there thinking about afterwards?
You really need to listen of what you're doing.
And why?
Because you might panic and drown.
Okay. Yeah, it's probably one of the first times that it was really important to pay attention to this. You're in total control of yourself. Nobody else is going to get you out of this. Great answer. Now, question for her is, are you ready to go out in the open ocean? What do you think?
I think I am because, I don't know, I think I learned a lot when I went to the PADI scuba diving. It was really fun, and they really teach you well, and it was really a good experience.
Okay, what was scary to you?
When I couldn't, get the air out of my mask, and I couldn't see anything, and I didn't know where the bottom or the top was, so I couldn't get up for air.
So in other words, it's good to be in a swimming pool and learn that first, isn't it? Yeah, it was a really neat experience and a chance for these guys to do this. Now, that's another way that you guys can get out, even at your age, and start learning. You know, like they said, these guys are limited to shallow water as they do it. As you get older, you can get in deeper. But let's go back to these cameras that we talked about before, and that we were showing you underwater how we could see things. We got some crabs and hermit crabs here and an interesting camera. Joe, what is this camera?
Now, this is a unique one. We call this the finger cam, and we give it that name because you put your finger over it. It's a high-resolution color camera, and you can see it is being pointed at a small shore crab that we collected from the beach yesterday. Now, the beauty about this is you don't have to go underwater. You can point the camera then in intertidal areas, in shallow areas, in aquariums, to get sort of up close and personal to many of these small animals.
Okay, I need to figure out where you're moving. Now, can you show us a hermit crab? Let's go over here and see a hermit crab that's crawling around. And hermit crabs are not as easy to see. They're little tiny things, so that this is really cool because we're able to get up closer to it and see it actually move here. There he goes. And did you guys know that hermit crabs, there's all kinds of different patterns, colored patterns on their legs and their antennas. And I was taught it's one way that you can identify them. Cool little camera. And this camera is one you can use on the surface, or you could also take something like this underwater, couldn't you?
Yes, you can.
And see up close, because for me, I always want to get up there and see what that final little thing is.
The finger cam's for you.
Finger cam, it's really a cool thing. Now, we have some other animals back here that we want to take a look at, and I have a special guest here, Mark Heckman from the Waikiki Aquarium. And Mark, thank you for joining us.
Thank you, Pat.
And you have a student helper here too.
I do.
And Mark has brought in what we're going to call the Critter of the Week, and we're going to have animals in here all week that he's going to share and explain a little bit about. But we're going to use a little technology with this too. So we have the same camera here that was used in the head of lettuce underwater, and the fish were coming. Same one.
Wow, excellent.
So this one went underwater. So I want you to look up close with this too. So
Let's start
Mark,
on that one.
tell me what you got here.
Okay, we have echinoderms today. Echinoderms. Do you know what an echinoderm is?
They got spines on them.
Excellent. In fact, we can take the name apart. What rhymes with echino, Meg?
Rhino.
Rhino. What does a rhino have?
Horns.
Very good. Echinodermata is their full name. If I said your epidermis had spots, what am I talking about?
Skin.
So these are spiny-skinned animals. And if you look at what she's got there, they're spiny. Wouldn't you agree they're spiny? Yeah, definitely spiny.
Okay, so where's the mouth?
Where do you think the mouth is?
Underneath.
Excellent. Yes, it is on the underside. And actually, this is there's some shells here of them. can you focus on the shell for a second here? This is the test. It's not a test, but we call this shell the test. And the mouth would be on the underside here. And actually, the mouth looks kind of odd. That's the mouth right there. Does your mouth look like that?
No.
No, I hope not. Yeah. This one has only 5 teeth. And the 5 tells that it's related to another animal we know. What animal has 5 legs? And it's down in here. Any guesses?
A brittle star.
Excellent. You are a marine biologist, aren't you? You been to college already?
No.
Okay, just checking.
She just lives on the beach.
Oh, okay. Well, go ahead. Point that down in there. Let's take a look at these. There is a, come up a little bit. There's a brittle star there that is headed for shelter. Now, the brittle stars during the day hide under rocks. I guess I didn't give it enough rocks. It's hiding under something. What's it doing there?
It's looking for shade because it's really bright.
Oh, cool answer.
She is so good. We've actually done experiments with these where we found that they do react to light, and they will move out of the light. So she had it right on. Let's look at our one other animal in here. What do you think those might be? Any guesses?
No.
Looks like a worm, doesn't it?
Yeah.
This is a sea cucumber. And actually, if we opened that up, we would find it has 5 long muscles running down the inside. So it's related to sea stars too. These are all related. The sea cucumbers have 5 long muscles. The sea urchins have 5 teeth. Or if we looked up through the test, we would see a star pattern based on the number 5. You want to try shooting right up through there with that camera? I don't know if that'll work or not. But you'd see a star pattern that's based on the number 5. So these are all related. And the sea stars, of course, start with 5
And you know
rays.
what I find interesting is that I can see that the 5 parts in the sea stars and the sea urchins, but it's a little harder for me to understand where the sea cucumber comes into it. But again, it's in the mouth area. Is that correct?
Well, also on the insides. Megan was noting that it was moving like a slinky earlier, which is kind of nice. They have muscles, and they have 5 long muscles that run down the length of the body. Did you touch that to see what it felt like? It looks spiky. What does it feel like?
It's soft.
We've got another kind of camera that we can use here that is taking us a little into the water in a little different way, and it's being used in some really cool ways. Joe, what are you going to do with this one?
Well, Patty, we've gone with the letters cam, the finger cam, but they were all connected by wires. And the next generation camera then is going to be wireless. And this is one of those models. We have a lens, a color camera behind it, and a wireless transmitter, and a little 9-volt battery. There are suction cups then allow this to be stuck under the dorsal fin of a dolphin, a whale, or on the top of a turtle. As the animal swims around, we can send images back then, and so the animal becomes the videographer. Now, we're going to give you a demonstration of this, and my animal, Ford here, what are you going to be today, Ford?
A seal?
Ford is a seal, and we've used these cameras on seals, and Ford is going to actually duplicate this by putting one of these wireless cameras on his head, where we would mount it on a seal. Okay? So what we're going to do is we're going to have you turn on the transmitter, which it's on, and we're going to have you pretend like you're a seal. So wirelessly, we'd have you move around.
Okay, now, tell me, wait a minute, before you go, I want to know, you're going out to look for something. As a seal, what would you be out looking for?
Food?
Food, so what are you hoping to find?
Seaweed.
Seaweed or fish or something like that. So, okay, let's send you out, and what you're going to see here, guys, is from the seal's point of view. If you tend to get motion sick, you just want to close your eyes at times. So here, put your camera up, and let's start walking. So let's go for it here and see what he can see. Remember, this is what the animal would actually be seeing. So he's walking along. He's looking for that fish. There he goes. We get little blips in this. It's just interference because of the
reflections. We have a high-power camera, and the signals then, Patty, are bouncing off all the metal that we have in the studio. Out in the field, then, we don't have these reflections because there are no metal around. But we see Ford moving through the water. He sees a bunch of fish. You can see this would be his perspective, or the seal's perspective, as the case may be, underwater.
Yep.
And we said that he's looking after what? Looking for food.
He's looking for food. Now, these cameras have been used here in Hawaii on some of the monk seals to see what the monk seals could eat. And what they found was oh, wait a minute.
Did he find some food over there?
He found food. So what did he find here? Okay, show us what you found. Hold it up in front of your camera. He found a candy bar here. Not quite the seaweed or the fish, but found the candy bar cake. So can you walk back towards us again? Kind of move the camera up and down. Show him what, if you were to put your head up, what are we going to see? Kind of go upward. He's going to see the lights on the ceiling. And see, now he's giving us this effect of looking kind of seasick here as he moves around doing this. When they put the cameras on the monk seals, they were looking to see what the monk seals were eating and actually doing research with it, so it's another way that these are being used. Okay, cool cameras, and you found your bounty there, didn't you? Okay, neat way of doing this. Now, we have another way that we can look at using technology to look at things in the water also, and this is through internet cameras. We're going to go to the Waikiki Aquarium and see how this works.
Here at the Waikiki Aquarium, we have 3 internet cameras that look into 3 separate tanks. We have a coral research camera that looks into one of our back holding tanks where we're doing research and studying coral growth. We have a camera over our monk seal pool where we can see our 3 native Hawaiian monk seals. And we also have a camera in our shark tank where we can see all the predators on the reef. Now, internet cameras are a way of getting a view of the tanks from anywhere in the world. And they allow you at home to go visit our website at waquarium.org to see these views of these animals anytime, day or night, 24 hours a day. Now, the internet cameras are connected via the same sort of cable you'd use on your VCR to a small device here in my office called a video server. And then that video server is connected to the internet, and then the internet is connected to our web server so that we're able to get the video images from our camera server to our web server to you. We want to give kids a view into our tanks that maybe you wouldn't get otherwise, and also gives the public a chance to see the tanks throughout the course of the day and during feedings and stuff like that, and it basically gives people all over the world a chance to see rather than just people who come to visit us in person. We get email all the time from people all over the world, from the state of Hawaii, from the mainland, from Europe, from Asia, from just about everywhere, about people who really like our cams. You see all sorts of interesting stuff. You can see the sharks being fed, you can see the sharks getting right up into the camera, and you can see the sharks resting down at the bottom occasionally. In the future, we're thinking about adding even more cameras and even doing some really cool stuff, like having cameras on remotely operated submersible vehicles. And you'd be able to drive these little ROVs at home over the internet and see the live video feed from that. In addition to being just plain fun, these cameras allow for all sorts of interesting research possibilities. Not only can you plot the growth of a coral, but you can watch animals 24 hours a day, 7 days a week.
Now, what we have for you guys here is a really cool assignment for the next couple of weeks. Okay.
I think so, yeah.
These cameras are located in the aquarium, but you all have access to them through the internet. Next week, we're going to show you more of what's actually in these tanks. But teachers, if you go into the kidscience.net site and find the lesson plans, you're going to find with each lesson a page of questions. And so we have 15 questions here for your kids to be looking at and trying to find answers to as they look through these webcams. What would you research and why? Let's go back to Florida, and Florida's got lots of cool stuff out there in your waters. Manatee, who is there this time?
It's still me, Jessica.
Okay, and what is it that you would want to research and why?
I would research the giant squid since no one has seen it alive in the water. I would take a submersible down deep into the water, and if I found it, I would research just the behavior in general. I would record all my findings, and it would just be a great it would be a great experience for science and me.
Wow, that's cool, guys. We're going to go down, use another kind of technology, and we're going to go down underwater again. This is off the coast of Kona on the Big Island in a passenger sub, which anybody, if you're a place where they got a sub, can go down and experience the underwater. So let's take a look at how this passenger submarine works.
Our submarine operation in Kona, like all of the submarine operations around the world, employs an Atlantis submersible. The submersible is a vessel that is able to submerge from the surface of the ocean down to significant depths underneath the ocean, but it is always accompanied by a surface vessel that is actually a command and control vessel. The submarines are 65 feet long and weigh 80 tons. The crew comprise a captain, an attendant, and an orator. So there are 3 people on board in order to maximize the enjoyment of all of the guests and to ensure that we operate with 100% safety. The submarine itself comprises, as all submarines do, a pressure hull. That's a cylinder that is manufactured to very, very high tolerances. It contains the viewports through which people look, and the viewports themselves are made of clear acrylic, and they're 3¼ inches thick. We have an expression which says that while we're under the ocean, we take only photos and we leave only bubbles. In other words, we don't add or deplete the ocean environment. And one of the reasons that we're able to do this is that our submarine is completely self-contained and operates on a set of lead-acid batteries. The oceans of the world cover so much of the surface of the planet Earth that there is so much for us to continue to explore, and we know so very little of it. There's limitless opportunities for people in the future to go into the oceans that exist on the planet, learn more, and work out how we can use that knowledge that we find from our development and progress of searching what occurs in inner space, which is our euphemism for the oceans of the world.
Submarines are awesome, and we're going to be going down in the Atlantis sub each week here with a group of students from the Big Island that are actually going to do some lessons from the sub. So today we introduced you to it. Next week we're going to actually do, like I said, some class work from underwater. It's a really cool way to hold class, I think. Now, these guys have built some subs here, and what we have, I'd like to challenge all of you to try to do this. They took soda bottles and they have made it so, tell me, what makes it go up and down?
First, when it goes down, the weights.
Let's put it down, okay.
They weight it down, and there's holes in the bottle that make the air and water be able to come out. And to make it go up.
Wait a minute. So to get down, we had to fill up the container with water, and also had some weight on us, but we added water in here to help it get down. Okay, so now what's going to get it up?
What's going to get it up is you blow air through the tube into a balloon that's in there, and the air makes it float up.
Okay, and as you blow into it, the air does what? Pushes out the?
Water.
Water. Okay, now let's see if we got enough hot air in these two. Can you guys blow these submarines to the surface? Keep blowing, keep blowing. It's coming, keep going. She's got a little air leak. This one's coming up a little faster, but it's coming up slowly here. Now, what was the most difficult thing about this one to you?
Was the even balance of the weight.
Okay, the even balance of the weights. Now, in construction of yours, what seems to be your problem?
It's really hard for us to fasten on the weights and to get enough amount of weight for it to sink down.
Okay, and we also have a little bit of an air leak here, which you wouldn't want to have in your sub to make it not go up and down. I challenge you guys to try this. This is not an easy process. And try it to make them even go deeper down. Now, Joe, if you were to use a submarine and you could go anywhere you wanted to and research something, what would you, if you were going to go away in this, I'd go in the orange one right now. I think we need to fix the air leak on that. You go in this little orange one, where would you go? What would you do?
Well, Patty, it's interesting because I recently spent about a month studying an unusual shark, the six-gill shark off Vancouver Island, and we used small 2- and 3-person submersibles that were identical to this little experiment in principle. Lead on the bottom, air in the ballast tanks to bring him to the surface.
And
so
orange balloons, huh?
We had no orange balloons, but I could use some great assistance like this down there. And sharks are my interest. Deep water, rare sharks like the six-gill are very, very exciting.
Okay, and what is the advantage of using a submersible?
Well, in a submersible, we can maneuver around. We've had a lot of the drop cameras which see a particular area, but the submarines then we can guide, we can control, we can take video, and we can make our own personal observations down there. So they're quite effective at studying underwater and deep water animals.
Okay, which is cool. We're going to go underwater more in the subs next week, but right now, before we leave you, Uncle Joe sent us a message from the bottom of Sea Life Park with his hydro mouse. Tim, did you finally get it?
I sure did. Patty, look what we got. We got some pictures. Uncle Joe sent us some pictures of you folks underwater. Look at Patty. There you are on the left-hand side. Uncle Joe's in the center. And Mark's on the right-hand side. And you're at a table in front of a computer. Let's look at the next one. What else did they do here?
So it really works, huh, Joe?
Yeah, there they
really
are.
works,
See, look
Patty.
at that. In front of a computer. And look at this next one. Here he is with a hydro mouse in front of his computer again. And the next one, feeding a stingray.
Okay, cool.
And the last one here, have you ever been kissed by a stingray? Look at that.
Cool.
Not bad, huh? Thanks, you guys.
Okay, so, we're still questioning how you made this work, but we did make the blue submarine come to the surface now. They just got enough hot air, and we came up. Now, I want to thank all you guys for joining us. Uncle Joe for being here today.
Thank you, Patty.
Uncle Joe's going to be underwater with me next week. Next week, we're going to be looking at habitats and where the fish live. And we're going to be using all these different technologies to get down there and look at a bunch of different habitats. So while we're gone for this next week, I really would like to see you guys get into the internet, get into those webcams, check out those animals at the Waikiki Aquarium, see what you can learn about them, and then start looking at different habitats. So when we talk about them next week, you'll know where we are. So we're going underwater again next week. Joe and I are going back down because it's really cool. So bye-bye, guys. We'll see you next time. Bye-bye.